Okay, so we're going to tackle two problems today dealing with the change of potential energy to kinetic energy. The first one is the skateboarder. He's starting at 10 meters per second. He has a mass of 40 kilograms, and he's going to go up a ramp. And we're going to find out what his potential energy, kinetic energy, and mechanical energy is at 0.2, as well as his velocity at 0.2 here, 2 meters up the ramp. Then we're also going to figure out how high up the ramp he can go. And the velocity at this point is going to be 0. I should have just put that in there. So the velocity at that point will be 0. So we want to know where he's going to basically stop at there. So we got to find the height, mechanical energy, kinetic energy, potential energy, all that good stuff. All right. And then the other problem is this roller coaster problem. We're going to drop a marble off this roller coaster. It's going to go down. It's going to loop around, and it's going to come here. We want to be able to find the potential, kinetic, mechanical energy at each point, as well as the velocity and the height at each one of these points. Okay. All right. So let's start with this one here. So at point 1, the potential energy will be 0 because he's at the lowest point here. So potential energy is 0. Okay, and that answer is in joules. We don't need to write out joules each time. I'm just pointing that out for here at this moment right here. Okay, the velocity is 10 meters per second. So that one, no calculations needed. Height distance from the ground is 0 meters. Okay, he's on the ground. Okay, now we need to calculate kinetic energy. So kinetic energy here is 1/2 mv squared. So 1/2 times 40 times the velocity, which is 10 squared. So 10 squared is 100 times 40 is 4,000. Half of 4,000 is 2,000. So the kinetic energy should be 2,000 joules or 2 kilojoules, however you want to write it. Mechanical energy, so something we really haven't talked about. Mechanical energy is just the sum of the potential and kinetic energy. So we have to add them together. And in this system, the mechanical energy should always be the same. It's going to be consistent. So it's potential plus kinetic, so 2,000 joules or 2 kilojoules. Okay, and we're going to assume that there's no friction and there's no air resistance. So this should actually be the same for all of these. 2,000 joules, 2,000 joules. Okay. Next, for number 2 here. Number 2, we have to find the velocity, the mechanical energy, potential energy, kinetic energy, right? Mechanical we know is already 2,000. Kinetic here, so kinetic is going to be a little tricky, but we can find the potential. We can't find the potential energy here. Potential energy is equal to mgh. So the mass, or 40 kilograms, times g, which is 9.8 meters per second, times the height, so 2. Okay, when I do that math, do my calculator real quick here. So 40 times 9.8 times 2, and we get 784. So that means that the potential energy is 784 joules. Okay, and one thing we do know is that potential plus kinetic will always be mechanical. So we can take the 2,000 joules minus 784, and that will give us the amount of kinetic energy. So 2,000 minus that, and we get 1216. All right, the height, we're actually given the height, it's 2 meters, so we don't have to do any calculations for that, 2 meters. Okay, and then the velocity, so we know that the kinetic energy, so in order to find velocity here, we know that kinetic energy is equal to 1,216 joules, right? And we also know that's 1/2 the mass, which is 40, times velocity squared, which we don't know just yet, but we're going to figure that out. We're going to solve for that. Okay, so we're going to divide both sides by 1/2 and 40, or in other words, 20. So it's 12/16 divided by 20. You get 60.8 equals v squared. So we take the square root of both sides, square root of both sides. Okay, so square root of 60.8. And you get about 7.8. So the velocity at this point is about 7.8 meters per second. Does that make sense? Yes, it does make sense. It's a little bit less than what we started with. Okay, a little bit less than what we started with. Next, we know that at this point, number 3, that the velocity is 0 meters per second. That's the highest point this is the highest point. That's what I'm just asking you to find. So 0 meters per second. So that means that the kinetic energy, therefore, is 0, because we don't have any velocity. If this is 0, then this must be 2,000. Because these two have to add up. These two have to add up to give you 2,000. All right. Then in order to find the height, or the distance from the ground, we use the idea that potential energy equals mgh. The potential energy is 2,000. The mass is 40 kilograms. G is 9.8, and we're looking for h. So we divide by 40 and 9.8, and we should get height. 2,000 divided by 40 times 9.8, and I get 5.1 meters. So 5.1 meters. So this little skater dude is going to get all the way up to 5.1 meters high, and then he's going to stop. All right. Okay, so the numbers are different in the problem that I gave you, so just be aware of that. The mass is different, velocity is different, this height is different. So these answers are not the same, but the principles and the way you do it is the same. Okay. Next problem, very similar problem here. A lot of the same principles that we're going to deal with here. The first one here. So again, I changed the numbers. So the first situation here, the first position, we have a height of 6 meters, a velocity of 0 meters per second. So we're starting at 0 meters per second. The kinetic energy is 0 joules, and it's all potential energy here. So we do have to solve for this. Potential energy here is mgh. So the mass of it is 75 kilograms times 9.8 times the height, which is 6. So that will be our potential energy. So 75 times 9.8 times 6, and we get 4410. Okay, and that's going to be the amount of mechanical energy. Okay, those should be the same. And the mechanical energy will stay the same for all of these situations because we have no loss of energy to friction or air resistance. All right. Okay, at point 2. At point 2, the height from the ground is 4 meters. Okay, the velocity, we do have to find that, but we're going to find that in a second. The potential energy. So here I like to calculate the potential energy first. So we know that the potential energy is 75 times 9.8 times 4. Because it's mgh. And we get 2940. Okay, and then to find kinetic, we just take the mechanical and subtract that. And we get 1470. Because these two have to add up to give you this one. All right. Then in order to find velocity, we'd say, okay, well, kinetic energy is 1,470 joules. And that's equal to 1/2 times the mass, which is 75, times the velocity squared. Okay, and we're just going to solve for velocity squared there. So divide by 1/2 and 75. Divide by 1/2 and 75. And take the square root of that, square root of that. So that cancels. Velocity equals 6.3 meters per second. 6.3 meters per second. Okay, next, point number 3 here. So 3 is on the ground, so the distance from the ground is 0. Okay, the amount of potential energy is 0, and the amount of kinetic energy is 4410. Right? Now the velocity, we use the same formula we used here. So 4410 equals 1/2 times 75 times velocity squared. Solve it the same way. So 4410 divided by 1/2 divided by 75, then square root of that. We get 10.8. Okay, next one. Okay, next one's probably the trickiest part. Okay, so here we have the velocity equals 5 meters per second. Okay, so using that, we can find the kinetic energy. So kinetic energy is equal to 1/2 times the mass, which is 75, times velocity squared. 0.5 times 75 times 25. We get 937.5. And we know this is already 5 meters per second. Now we didn't have to calculate that one. Now potential energy. So potential energy is that 4410 minus the kinetic energy, and we get 3472.5. Okay, and then we want to find the height from the ground. So the height from the ground is the potential energy. So potential energy equals mgh. Okay, and this is 3472.5. M is 75. G is 9.8. And H is what we're looking for. So just solve for H here. And I got 4.72. I'll just make it 4.7. 4.7 meters. Okay, so really just plugging in. It's kind of a little bit of a brain teaser here. You're given a bunch of things and you just got to figure out how to find the other stuff. All right. So good luck with that. If you do have any other questions, please let me know. I'm sure you all can do it.